So, tēnā koutou katoa, ko repani te whakapaparanga mai, ko mangawhau te kāinga, no tamaki makaurau aho, ko Mercedes takoinga, tēnā tātou katoa. Good morning, everyone, and welcome to the New Zealand Research Software Engineers Conference of 2024. My name is Mercedes Randall, and I co-chair the RSE AU NZ Steering Committee, as well as serve as a Research Communities Advisor at NZRSE, New Zealand's national e-research infrastructure provider. I'd like to extend a warm welcome and thank you for all taking your time to join us today. And I'd also like to give a special thank you to Michael Steedman from the University of Auckland for providing us with this morning's mihi whakato, which we'll play for everyone now.
Kia ora tātou katoa, nau mai ki tēnei huihuinga o tātou. Ko Michael Steedman tōku ingoa, kai te kaiarataki I roti te tari o te ihouluku Māori, ki konei Waipapa Taumatarau, University of Auckland. Morning everyone, my name is Michael Steedman, Deputy Pro-Vice Chancellor Māori here at Waipapa Taumatarau, University of Auckland. And I'm going to offer shortly some words of welcome. I'll begin firstly with a karakia. So I'm going to return back into Te Reo Māori, after which I'll offer some explanations over some of the words that I've said. Nā reira, ko te kupu, ko te amorangi ki moa, ko te hāpai o kimuri, kia ino I tātou. Tikena atu rā te pūtake o ngā kōrero, tikena atu rā te hautapo ngāriki. Kai whatatia tāne te wānanga ki ringi ki enei ruanaku, kia koe te matapuninga, mainga I te matapu iho ki haka maua I kia tīna, haumi e, hui e, tāe ki e. He aha te hau e wawara. He tiu he raki. Nā ia mai te puputara ki he kiota. E tikena atu e te kotu ko I te pau whakaro ka tū ki te waitamata I oku wairangi e. E ti hewa mauri ora. Iaku nui, iaku rahi, koutou katoa, ngā muka tangata. Ko rangi tāmiro tia nei, rungi tēnei kaupapa hui a kai manawa. Hara mai. Hara mai ki tēnei kaupapa o tātou, ngā mātanga katoa, puta noa tēnei motu o tātou, hara mai. Harang mai I rungi te karanga o tēnei wānanga o tātou a Waipapa Taumatarau, University of Auckland. Nā mātou te whiwhi ki te whakatū tēnei kaupapa kia koutou katoa. Whakatau hoki I roti te reo nei a Ngāti Whātua o Rākei, e mihi ana. Ki ngā tini whakapono o ainga nui a tātou, e mihi ana kia koutou I roti te rangi Māori. Kei ngā mate, huhu o te wā, urungi a mātou ki tēnei wā, rātou, kua whitirangitia ngā mate katoa haere atu rā. Huri taku whakaro ki te kēngitu heitia, ko haere kē, ki ngā whare manahua, ki tōna tātai ariki, e te kēngi e moi. A rātou kia rātou, noho ki reira, a tātou kia tātou, noho mai ki kau nei, ngā mōrihutanga, ngā mata, o rātou, o whitirangitia, o rātou ngā mātua tupuna, a tēnā koutou, a tēnā koutou katoa. Ai, nōku anō te whiwhi ki te tuku I nei kupa mihi kia koutou, me kore anō, ka whai koutou katoa, he ara pai, me ngā hua I roti tēnei huihinga o koutou, tēnei wānanga o koutou. Nā mātou anō I roti Waipapa Taumatarau te whiwhi, I te whakatū tēnei mō tātou katoa, ki te whai ngā mea miharo, mō tēnei motu, me tēnei o tō tātou āhoki a tēnā koutou katoa. Hoi anō, a huri ahau, ki te reo o tōku tupuna, John Manfred Steedman, whakamāra mai tātou katoa. Morning everyone, just again reiterating some words of welcome and best wishes for the conference ahead. I just wanted to make a brief mention of the theme for the conference, empowering communities through research software, from innovation to impact. Now, this in particular has some resonance in my particular cultural space when I think about what is known as tikanga or cultural practices, really tikanga methodologies or systems which allow us to operate in a particular way. And so if I think about engaging communities and empowering communities through the development and use of research software, In essence, you're producing a type of tikanga. And often tikanga have to respond to situations, so old ways of doing things need to be adopted in order to accommodate new ways of thinking. So with that, I just want to acknowledge you all as practitioners of tikanga, to use my cultural comparison and to acknowledge you all as experts. I want to acknowledge in particular the keynote speakers, and lastly, acknowledge those that are responsible for putting this whole conference together. So in the words of my ancestors from this particular part of the country, ka nawhitea noa moku, that's enough from me. But I want to wish you all the best conference. Kei te mihi kia koutou katoa. Tēnā koutou, tēnā koutou, tēnā tātou katoa. One of the things that we do at the end of a formal speech is we offer a waiata of some sort. So I'll do that now with the invitation to any of the speakers of the conference. If they wish to sing a waiata or something similar in their own culture, they certainly can. However, this isn't compulsory. Hoi no, mihi ana kia koutou, tēnā koutou, tēnā koutou, tēnā tātou katoa. Ruia, ruia ngā kāka no I te moana nui a kiwa, wheraia ki te moana rongo nui e rea, ngā waka ki te pau whakairo ka tūki, wai I te mata, I raro I te maru maru o ngā maunga tapu ko wai, papa te mana wa whenua, o wai papa tau matarau. That waiata is available on the university's Te Kuaha app, Te Reo Māori app, so feel free to download it. It's free on all the usual places. I'd now like to hand back to this morning's host.
Thank you to Michael Steedman for providing us with this morning's mihi whakato. Before we get started, I need to say that we do have a code of conduct in place to ensure everyone feels respected and welcomed. So please just take a moment to review it on the RSE conference website. And we ask all attendees and speakers to follow this code throughout this event to help create a positive and inclusive environment. Right, we'll move on now. And as you all know, this year's conference theme is empowering communities through research software from innovation to impact. And we have an exciting lineup of talks ahead. If you haven't already, I encourage you to review the program on the NZRSE portal or on the conference website. And I'd also like to give a special thanks to our keynote speakers, Dr. Andrew Chen and Dr. Erin Kwan. Dr. Chen will be delivering his keynote just after this welcome session at 10 a.m. New Zealand time, and Dr. Kwan's keynote will take place tomorrow morning at 9:40 a.m. New Zealand time, both of which are going to be great talks and not to be missed. The portal that we are operating in has the ability to be able to chat with other attendees and presenters in the meeting hub, which you can access on the right-hand side of your timeline, and we encourage you to use this throughout the conference to participate with your peers. We've been using this portal for our conferences over the past few years, and while we've been continuously working to improve your experience, I would just like to thank you in advance for your patience with any technical difficulties that may arise unexpectedly throughout the conference. During the session, if you do happen to experience any technical difficulties, can you please click on the red live support button at the top right-hand corner of your screen. I also ask that you please check your notifications on the portal regularly for any updates. And before I sign off, we do have a Q&A box. So if you have any questions, can you please type them in there, and we'll give you a moment to do that, and then we can get into the next part of this session. Okay, it doesn't look like there's any questions coming through. So thank you for your attention for this part, and I hope you enjoy the conference program and networking with your peers. I'll shortly be handing it over to Michael Carrick, who will be the chair for this morning's first session, which is not set to begin until 10 a.m. So until then, just make yourselves comfortable, and we will start the conference with our first keynote session very shortly. Hi again, everyone. I've just been informed actually that Michael and our keynote, Andrew Chen, is here, so we may as well get going now. So I'll now pass over to Michael, who will introduce Dr. Chen.
Kia ora. Welcome to NZRSE Day 1. As Mercedes said, my name is Michael Carrick. I'm the CISO for NZRSE, as well as the Deputy CISO for Research at the University of Auckland. I'm very pleased to be here with you today, introducing our first keynote speaker for this talk. The area in which he works is very near and dear to my heart. So it's good to see more research going on in this space. So Dr. Andrew Chen is the Chief Advisor for Technology Assurance with the New Zealand Police. He focuses on supporting the legal, privacy, security, and ethical risks associated with the police's use of new technology. In particular, he did some work on facial recognition as part of the COVID-19 response. And he's going to be sharing some of his work on us around bias and moving towards AI safety. He has really furthered this space, and we hear a lot about what bias in AI is, and it's a very fast evolving field, and so I am looking forward to his talk. Please join me in welcoming Dr. Andrew Chen.
Great. Tēnā koutou katoa, no Taiwana no tamaki aho, ke te whanganui a tara taku kāinga, no reira kia ora mai tātou. Thanks very much everyone for having me. I'm very glad that it is an online conference because you may be able to hear from my voice that I am a little bit unwell. So I do apologize if I need to quickly duck off screen to have a bit of a coughing fit. Yes, and I'm going to spend the next sort of 30 minutes or so talking about AI and bias. Afterwards, very happy to take Q&A on anything, so not just necessarily limited to what I talk about here. I'm aware that I have a pretty interesting role with the police, which I'm not going to cover in my presentation. And so, if anybody does have any questions in that regard, please do feel free to stick it in the Q&A. And so, yeah, I'm here to basically offer some hot takes on AI and bias and some ways for you to think about some of the media coverage that you see about AI systems performing weirdly. Feel free to, stick Q&A in there. I think there is a chat function, but I can't see it. And so, feel free to use the chat, but I might not be able to interact with that. And I'm aware that this is a relatively technical audience. I'm guessing that most of you will know a lot about how AI systems work, have used generative AI tools to help you write code, for example. But not everyone has, so I will try to keep the technical details relatively simple. There's very little math in these slides, so hopefully it is accessible to the all audiences. Before I go on too far, just a bit about myself. I do have a technical background. So my PhD was in computer systems engineering. I was doing AI and image processing applications. Here's me playing chess with Bax the robot because no one else wanted to play chess with me. As it turns out, when you give a robot a chess engine, it will beat you every time. I started in sort of AI machine learning and then moved a little bit sideways towards ethics and privacy, particularly around camera surveillance. I ended up in the Faculty of Arts at the University of Auckland, part-time for about 5 years before I landed in my police role now. So my research has primarily been on technology, ethics, and public policy, primarily public sector use of digital technologies. Spent a lot of time during the pandemic working on NZ COVID Tracer and also putting together a book called Shouting Zeros and Ones, which is one of maybe 2 or 3 books that cover digital technology issues in an Aotearoa New Zealand context. And then now I'm Chief Advisor, Technology Assurance at New Zealand Police. I still hold an adjunct senior research fellow position as well. What is AI bias? And this is where I would ask you to do some audience participation and to put something in the chat. I can't see the chat, so I just ask you to imagine. When I put up the word bias, what is the first word that comes to mind? And probably the words that you're thinking of are things like discrimination, bad, erroneous, to be avoided. And, the headlines would tend to agree. Here are a couple of headlines about AI and sort of, the issues with AI and trying to get people to think about the dangers of AI. You have automated discrimination in the top left, why AI bias can hurt your business, how are we making sure that AI machines aren't racist. I like this one here from the ABC, noting that, here's a picture of what a psychopath AI is supposed to look like. And even the Pope, of all people, has a view on this, and views that there is a need to push back against evil AI. And I've got a quote there at the back end that, he's worried that AI will amplify societal racism, sexism, and other forms of bias. And this is bad, says the Pope. So before we can really sort of delve into this in too much depth, we need some sort of definition. And so what is bias? There are maybe perhaps different ways of thinking about this, and different fields in particular will have different definitions. But one definition might be a deviation from an equal outcome that impacts some people more than others, and generally identifiable based on protected characteristics. So protected characteristics are those enshrined in law and human rights as being things that we shouldn't discriminate against, like age, race, ethnicity, sex, sexual orientation, disability, religious belief, marital status, political opinion. You can start to see that, at the beginning of that list, things like age, race, ethnicity, sex, and sexual orientation may be relatively easily identifiable. Those ones towards the end, religious belief, marital status, political opinion, perhaps harder to really ensure that your system is bias-free. And so this is a relatively, engineering type definition where, in my mind, I'm picturing a signal and you've got a line and that line is maybe going up or down from where it should be. And so we've got a deviation from the outcome that we're trying to achieve that would be equal. So what causes AI bias? You'll all have seen diagrams like this, a representation of what's going on inside an AI system. Each circle represents an artificial neuron, which does some computation and then passes the output to the next neuron, so on and so forth. And we can split these three sections up into the input layer where the data goes in, so sort of like the sensors, your eyes or your ears. You've got the hidden layer where the computation happens, so that's sort of like the brain that processes the data, and then the output layer where the results come out, sort of like the mouth or the muscles that act depending on the computation. And so the two key parts in this system that actually lead to AI bias are in the input layer and the hidden layer, which can be discussed in terms of the training data and the architecture. So I have two exercises that will just help us understand these types of errors in a little bit more, less technical terms. So here we have a selection of hieroglyphs from ancient Egypt. And again, just, think to yourself, what are the things that make them common with each other? What are the patterns that you see? And imagine that these images are all the only images that you get to see about hieroglyphs. And they're given to you as the only examples of what hieroglyphs look like. Probably you identify that there are people in all of these hieroglyphs, that they're side on, that they seem to be doing things. Not entirely sure what's happening in the last one with the two giraffes, but generally in the other ones, they're doing something. So, in this sense, we have trained you as a human to understand what hieroglyphs are. And then we can test that understanding. So we can show you this image and ask you if it's a hieroglyph, or this one, or this one. And they probably look different enough to the others that you might say, no, these are not hieroglyphs, but they are. They're just perhaps rarer ones. If you ever needed to know how to express intestines in hieroglyphs, then it's the middle one of these three. And there is a lot of diversity out there. There's all sorts of hieroglyphs out there, but the most common ones do tend to have people in them. And so the top row might be what we call a biased data set. And in statistical terms, it's a sample that is not representative of the population, or in perhaps normal people terms, it's like watching the trailer and thinking that you've watched the whole movie. So in the second exercise, if you like IQ tests, you might like something like this, and this is a relatively technical audience, so maybe you will know the answer to this. But the question is, given the outer two images, what does the image in the middle look like? Okay, so what we're asking for here is, what is the relationship between these images? So I have two examples of what the pattern is supposed to be. And given this third example, what should be in the middle? And so, yeah, again, as a relatively technical audience, one of you might identify this from a textbook, but non-technical audiences are totally going to be befuddled by this. And so the answer is a two-dimensional Fourier transform. But even the most mathematical of us will probably struggle to do this transform, this calculation in our heads. We have modern computing and we have visualization tools to help us understand what's happening here. And it could be argued that this is a mathematical operation that simply does not map neatly onto our brain architecture. It's not something that we can express easily in human communicable language. Perhaps, we have mathematical notation to help us there. But it is pretty much impossible for humans to really visualize what's happening in a two-dimensional Fourier transform with our modern computing tools. And you could say that maybe the biological tools that we have available to us, i.e. our brains, aren't good enough for this type of problem, and that therefore the architecture is lacking. So when it comes to diagnosing and treating AI bias, the architecture is very, very hard to fix. It's constrained by hardware, the number of GPUs people can get their hands on, and the way that engineers connect those artificial neurons together. It is relatively rare to achieve disruptive improvements in the architecture. We seem to get a breakthrough every couple of years that seems to significantly change the way that we think about doing AI and change the performance rates. The vast majority of AI effort is relatively incremental in terms of the architecture. And so instead, most of the effort has gone into improving training data, and in most cases, just hoping that if we get more of it, then it'll become more representative of the real world. And so this is MNIST, which will be familiar to many of you. One of the original and most well-known data sets for training AI systems. It was released in 1994, and it had 60,000 images of handwritten numbers, all labeled, which was an insanely large data set at the time, right? And they wanted to be able to read handwritten postcodes to sort the mail. At the time, massive data set targeted towards a very narrow problem. We look at the data sets that we have today, and Leon is the data sets that use to train Stable Diffusion and Midjourney and some of the other image-based AI systems. And it has, the 5B stands for 5.85 billion image text pairs in multiple languages. There's 6 orders of magnitude more data in about 30 years. But this represents, almost everything that humans have placed on the internet. It's hard for humans to appreciate just how much data that is, because, we can't express it in terms of Olympic-sized swimming pools or American football fields. The data has been gathered and scraped from the web without human supervision largely, although in some cases we have underpaid labor in the global south used to clean the data set. And this is just a subset of what comes up when you search for the label French cat. There's a lot in here already, but, here is where I would ask the audience, what is the obvious problem here? I would say that there is a significant issue in that these human labels all come with their own biases, because I would say that these are cats that are stereotypically French and have stereotypically French characteristics rather than cats that are ethnically French. And so if we were to say a French cat, you're unlikely to get a cat that's actually ethnically French. You're just going to get a cat that looks like it could be stereotypically French. Which leads us to this next section. What's biased about this question of bias, or rather what's biased in the way that we talk and think about bias? And so we all talk about bias as a bad thing generally, but the issue with our definition, this first part of the definition, a deviation from an equal outcome, is that reality is not equal. And one of the issues that we are finding in the world of AI safety is that people are not necessarily doing a good job of distinguishing between reality and aspiration. The standard defense against bias is that reality does not match our ethical aspirations. And, therefore, that's what we're teaching AI. Here are some examples. So you ask DALL-E to generate an image of doctors, and apart from the horrifying eyes, you could argue that, 65% of doctors globally are male, so maybe this is accurate. You ask for an image of nurses, and 77% of nurses globally are female in the age group 35 to 44. And again, so this could be argued to be accurate. And then I asked for an image of bad drivers. And yes, if they're asleep, then they're probably bad drivers. But also the AI reckons that they'd probably be Asian. And you kind of go, wait, hold on a minute. Is that accurate? So I, wanting to sort of correct the record, I went out and had a look at some data sets. And it turns out that Asians have the lowest fatality rate of any transportation mode of any ethnicity in the United States. And so that would be one argument, perhaps, to say that actually this is a incorrect image. And so the issue is that these images don't represent a desirable outcome or the future we want. If we give AI the data of today, it will reflect that back to us. But even worse than that is that the data of today doesn't actually represent reality. It comes loaded with human biases and stereotypes, and without intervention, the AI will learn that too. The word reality here is quite misleading, because when we say reality, it's the reality that has been constructed by humans rather than necessarily objective truth. And so one of the common responses to this problem is to intervene and say, let's put some safeguards and some guardrails on this. And so we can say, let's generate an image of doctors that reflects ethnic and gender diversity. And so that could be something that we put in the prompt. That could be something that we put at the end to kind of filter the outputs of our AI system. But this can go wrong too. Here are some images from a scandal earlier this year where Google's Gemini AI produced ethnically diverse Nazis, and it wasn't prompted to reflect diversity, but the developers had added controls to try and remove bias. And oddly, people criticized Google for having developed a woke AI that cared more about diversity than historical accuracy. Officially, Google disabled image generation of people to avoid generating historically inaccurate images, rather than because it might be bad to put white supremacy insignia on people of color. Never mind that. But even now, 6 months later, in an era where progress in AI is measured in weeks rather than years, Google only recently re-enabled image generation of people, and only for paid users. So there's a really significant challenge here, even for the likes of Google, in trying to solve this sort of problem. And so perhaps one of the fundamental problems in our general approaches to AI safety is that most of the efforts to address bias are not targeted at the input layer or the hidden layer, where we've sort of identified that the bias originates, but at the output layer. Guardrails are put in place to filter the outputs or adjust them. So we tell the AI system chatbots shouldn't give responses that encourage crime or select output images that are ethnically diverse. And it's a lot easier technically to add those guardrails than it is to go get more data or to get better data, because it's boring work and it costs money, or to evolve the architecture, which is conceptually and technically difficult and costs money. What we keep finding is that people can get around these guardrails by coming up with more creative ways to ask for what they want, or even worse, when the system is released open source and people just remove the guardrails themselves. So what's going wrong? And, I apologize here for the technical and engineering folks in the room who might feel a little bit stereotyped here and put into a box. This is a very broad and sweeping statement that I'm about to make, but it makes a lot of sense for the policy audiences that I tend to talk to. Perhaps what's going wrong is that we're telling the engineers discrimination is bad, bias causes discrimination, so in order to eliminate discrimination, we eliminate bias. And what the social scientists might say is that actually negative discrimination is bad, positive discrimination is sometimes good. Eliminating bias would eliminate both of these. And the bias discussion is often lacking in this nuance because it just assumes that all bias is bad. We all just assume that bias is bad. And eliminating bias removes the opportunity for the AI to do better than that human society that we have today, and to maybe reflect the future that we want, to maybe reflect those aspirations. So I often then get asked, what is positive bias or positive discrimination? Because we've been so trained to think of bias and discrimination as being bad things that people struggle to come up with examples of why bias and discrimination might be good. And so I come back to this definition: a deviation from an equal outcome that impacts some people more than others, generally identifiable based on protected characteristics, to try and achieve an equitable outcome. And so if that's what we're optimizing towards, then we might be able to actually use these AI systems to reflect the reality that we want. So here are some examples of real world things that we're already doing that are positive bias or discrimination. So for example, having paid parental leave and flexible return to work for people who have children. We have scholarship programs for underrepresented or disadvantaged groups. We allocate school funding based on student need. This used to be the decile system. Now it's called the equity index. We have digital inclusion workshops that are targeted at older peoples because they tend not to be as digitally included. And we hire more social workers living in low socioeconomic areas where that's needed. What's behind all of these is a recognition that people are not all equal, and that an equal treatment or intervention would leave some people behind. And you can argue whether or not these are good interventions or not. You can argue whether or not they'd be effective, or whether or not they would be a good use of money, or that, whether or not it's fair. But generally speaking, the intent is to be more equitable. And you can probably think of many more examples from your own personal experience. So instead of thinking about bias, I'd like to ask everybody now to instead think about fairness. So what is the first word that comes to mind when I say fairness? And probably there are variations on good, desirable, positive, equal. Of course, I've already biased your mental thinking by talking about why positive bias or discrimination is good. And I think it's relevant for us to kind of just think about that language, and that the word bias, from a technical basis, can be both good and bad. Fairness can also be good and bad. It's just a measure. How fair is it? It can be very unfair. But by changing that word to think about fairness instead of bias, our default directionality in our mind changes. So as we continue to move and develop AI systems at breakneck speed, we need to move towards AI safety. We need to move towards systems that are going to be for the people and keep people safe. I have a quote here from Sri Amit Ray, who is a pioneer of the compassionate AI movement. He was a meditation guru before he discovered AI, and did a hard pivot towards thinking about the values behind AI. And he's inspired by his teaching on meditation, peace, and compassion. And he says, the evolution of AI should always be guided by shared human values, the protection of human rights, and the survival of future generations. And, I'd like to think that this is something that we can all agree on. But this is a different set of goals and objectives than what is currently present in AI labs around the world, where people are trying to achieve 0.1% more performance or accuracy in their AI systems. They're not necessarily thinking about human values, although the big tech companies would all say that they are. I had a big argument with someone who'd recently been to those big tech companies and said, they're all worried about this stuff. They're all trying to make their systems safe. But I think, you have to judge them on their record in terms of the actual outcomes, rather than necessarily the fact that they tried. They're not even trying very hard, given that they keep firing all of their trust and ethics and safety teams. So it's hard to, really accept that the values of these big tech companies that are running and developing these big AI systems are well aligned with the rest of society. And so how might we achieve AI guided by human values, or how might we instill human values into AI? And there are a couple of principles that I can talk about here. So we can build safe, more limited systems with known bounds, and by thinking about that scope definition. Maybe we don't need a large language model that can respond to literally any conversation in the world. Maybe we're running a law firm and we just need a system that can extract knowledge from legal databases and provide answers. Maybe we don't need to train on the entire internet. By actually restricting the scope of what we're trying to solve, we can actually produce better outcomes through that technology. We need to think about what equitable outcomes look like. We kind of have to move beyond vague terms like it needs to be fair, because that's really subjective and difficult to implement from a technical perspective. Like if I can imagine being one of these AI engineers and just being told, make it fairer. And you're kind of going, well, quantitatively, how do I do that? So we need to know what we seek to achieve. Otherwise, we will seek to focus on quantitative metrics rather than some of this qualitative stuff that is a bit harder to measure. We can monitor performance to detect negative outcomes. So this is oversight. We're still a long way away from being able to do things perfectly. And so we need to have appropriate governance in terms of oversight and auditing to know when things are going wrong so that we can do something about it. We need to think about opening up the black box. And this is, transparency and explainability. I'm not going to go too much into this other than to say that, this is just about giving people confidence that their human values are perhaps reflected in how they understand these AI systems, and give us those opportunities to fine-tune and adjust how the AI system works. And lastly, we should be actively engaging with people and communities. And this is one of the things that the big tech companies are not doing. We can only reflect the human values of the people who will be using these AI systems and who are subject to these AI systems if we talk to them. And that seems like a obvious outcome, but it's something that everyone who is developing an AI system tends to steer away from because it's difficult. You have to deal with humans and they're unpredictable as opposed to the nice safe confines of the code that you're writing on your screen. It's really problematic when you've got AI engineers who are kind of stuck in their own little bubble of talking about P-doom and the likelihood of AI systems ending humanity as we know it, when you've actually got people who don't know the first thing about AI, but are worried. We need to make sure that these are the people that are coming along on this journey with us. And none of this is new. These principles have been well identified and described for decades now. Every time somebody does an exercise to figure out what ethical AI principles are, they tend to come back and arrive at the same place. The challenge is that it's hard to implement these things, and it's hard to force people to care about them and to resource it appropriately, especially when the overriding mentality of those building AI systems tends to be to move fast and break things. So again, we need to be building systems for the people. And I just put up this statistic from the Ipsos New Zealand AI Monitor. I think it was published in June. Lots of people are still scared about AI. In the technical community, it can be easy for us to be caught up in the hype and to see all that progress that's being made on a weekly basis in the AI space. I get a daily newsletter and I'm like, okay, this stuff is cool. We're making progress here. And I have confidence that, as we go forward, we're going to be able to solve some of these problems. But most people are not reading the same news sources as us, and most people are not as up to date as us. And so fear is a totally rational response to the unknown. So for all the discussion about AI safety, I think there is a fundamental point that we need to get our heads around, which is that people don't want AI to reflect reality. Because if they did, then they would accept that AI is sexist, racist, ableist, and so on, because that isn't our reality. And if we just give the AI more data to learn from in the hopes of better emulating reality, then we're just going to get more of those problems. Instead, people want AI to reflect their values. And what better place to start with that than fairness? So in a nutshell, if there's one thing that I can leave with you is that next time, instead of just focusing on how we can avoid bias in AI systems, I encourage you to think about and talk about how we can improve fairness in AI systems to help make them safer for people, to help make them better reflect human values. A simple change in mindset might lead to very different approaches and outcomes, where instead of thinking of it as a problem to be removed, it is an objective for us to optimize towards. Thank you very much. That's it from me. Feel free to email me if you want to have any conversations afterwards, but otherwise, open to Q&A.
Thank you, Dr. Chen. Appreciate that very informative talk. I've learned that we can all influence this conversation as part of adopting how we participate in these, because as research software engineers, we're always part of this conversation. And if one small voice can help make a difference, we need to take that opportunity. So thank you for that presentation. I encourage anyone to post your questions into the question and answer space so that we can explore and chat about that with our expert here. And I'll give a minute or two to get those typed in, and we'll go from there.
Yeah, while we're waiting, quick shout out to NZRSE, and thank you, NZRSE, for all of the work that you folks do. Certainly was something, an infrastructure that I was able to use during my PhD, and probably wastefully using cycles by running parameter sweeps to try and get, optimal outcomes. So yeah, huge shout out and thank you to the NZRSE folks for keeping that all going.
We've got a kudos here from Janet saying thank you, and it's an amazing how fast the industry is changing and that it's hard to keep up. So perhaps while others are entering their questions, I've got one that might tempt our technical audience a little bit. And given that our research engineers are involved in these conversations and they're writing the code, they're validating the results, they're there at the coal face, the screen, putting it together. What are some approaches or methodologies that we can adopt and leverage as part of working on the next implementation of an AI model within a system we're building, or approaching those conversations with the teams we're working with?
Yeah, so I think that in many cases it is about taking that conversation beyond the technical and to understand the social impacts of what it is that you're doing. It can be easy to kind of just tell yourself that what you're doing is only technical and that you don't have to worry about the real world impacts of it. But somebody in the team needs to be thinking about that, even if it's not necessarily the person who's writing the code. If you want those systems to actually be used in the real world by real people, then, even in the software world, we would talk about the need for UI, UX research and to, actually engage with users and understand their stories and so on. This is a version of that, right? It's just that instead of just looking at only usability, we're looking more broadly at other impacts of the use of this technology. One of the frameworks that we use at police is that there's sort of 4 pillars that we're looking at. Legal, which is relatively clear-cut. Privacy, which is a little bit less clear-cut, but there are general principles for us to apply. Security, which is mostly best practice, and then ethics, which is, whatever 2 people can have a discussion about. And the point of that framework is just to kind of remind ourselves that, as we move beyond the technical, these are the sorts of things that we're going to have to worry about when the rubber hits the road.
And we'll use that as a pivot into Alex's question here. How much AI does the police use today?
Yeah, so firstly, on terms of generative AI, there's a blanket ban still. ChatGPT, Google Gemini, that sort of thing is currently not allowed. I believe that there are 1 or 2 trials being run by ICT to just explore what that might look like going forward. but at this stage, there's none. In terms of other forms of AI, there's a little bit of facial recognition, a bit of number plate recognition, a little bit of process automation, although I would, hazard to say that that is not really AI, but people call it AI because it kind of, the term's been misused. And the other one is, when you're controlling drones, it's practically impossible to fly a drone without some form of AI assistance these days. So those are really the only places where AI is being used today.
Our next question is here from Hillary. It's given that AI models are trained on real human-generated biased data, is it generally considered to be even possible that AI models can deliver results that avoid those underlying problems in the data? And that bolting on post hoc constraints, filtering seems kind of kludgy and seems to be fragile.
Yeah, so if we were willing to spend some more time and money on it, we would curate our input training sets better. And there are systems where this has happened, where the bias is a lot less. So as an example, there are now LLMs that are being targeted specifically for law firms and policymakers, where hallucination is not an acceptable outcome, and bias is not an acceptable outcome, and so those companies trained on less data. And you might say, well, that's not going to be as good a performing LLM anymore. You kind of say, well, by what metric? You're saying that this LLM isn't going to be able to pass a year 10 math test. That's not what we care about here. The law firm just wants to, get some help writing memos and briefs. And so by restricting that training data set to just what is actually needed and curating it to remove the stuff that might be more or less biased, that they're able to achieve better outcomes that way.
Yeah, I think that also ties into a statement here from Alex, is it's bringing humans more into the training of that training data set. It's imposing, for lack of a better word, a little bit of our own positive bias and value statements into what will determine the outcome of these AI models.
Yeah, absolutely. And I know, so Alex's question here, would it make sense to pair humans and AI for decision making? It does make a lot of sense in many cases. And, if in any system, for example, that police that uses AI is not going to lead to automated decision making, there'll always be a human in the loop. One thing that we do have to be cognizant of is automation bias. And this is well documented, that over time, people tend to just agree with what the computer tells them. And they start to lose that sense of the human in the loop is there to sense check. So we need to find ways to kind of combat that as well.
Let's go to Paula's question here. So would you say that is positive bias good for specific groups? And then how do you influence the possibility of reusing that system for other groups?
Yeah, so I think that it depends on what it is that you're trying to do and who your stakeholders are. I'm coming from a more public sector perspective, and there is a higher obligation perhaps to communicate and consult with your affected communities than perhaps in the private sector. That being said, I think that by communicating and consulting with your affected communities, that will lead you to develop a better product anyway. So it's not exclusive to the public sector. It's important to identify the correct, communities to engage with. And there is also, an issue around consultation fatigue, where, the same groups of people are asked again and again about their views and how to do things safely and so on, and often not paid for their work, and just, that it's expected that consultation will be free. So there are challenges in that space. I'm not saying that, just go consult, it'll be easy. But But I think part of it is just encouraging people to actually build that into their project plans from the beginning so that it is appropriately resourced, rather than something that's tacked on at the end and you're kind of going, oh, we've got 2 weeks left, we better go ask some people about, how does this make them feel, and kind of doing a not very good job of
it. So here's a straightforward one from Nick. Do you have any thoughts on the recently announced GovGPT platform and the risk and rewards of opening that kind of tool up to public use?
Yeah, I haven't spent a lot of time with GovGPT. I've read some articles, and I'm not even sure if it's available yet, so I haven't sort of played with it. Apologies to anybody here who works for Callaghan and was involved in developing it. As far as I can tell, I'd characterize it as an alternative interface for accessing government information. I think that there's probably been some, I don't want to say misinformation, but sort of false hopes that GovGPT was going to be this thing that meant that policymakers could automatically write their briefing papers for ministers. It's not that yet. Right, it's essentially ChatGPT or GPT-4 with a limited input data set, or a focused data set of government information. So from that perspective, if it leads to helping more people find the information that they need more easily, then that's a good thing. I think that they've probably done what they can to mitigate hallucination and errors, but that remains to be seen. And I'm sure, if that is not done properly, then, upon release in the first week, we'll be seeing lots of memes of GovGPT told me XYZ that was wrong. So there's a lot of pressure there to make sure that the system is as error-free as possible, perhaps.
Yes, so I think that actually leads well into Alex's question, which is how we fund and approach to the development of new models and AIs, in that a lot of the funding seems to be focused on performance, and perhaps the funding model should shift away from that to encourage a better outcome, one that reduces hallucinations, so that GovGPT doesn't give you advice that's against the law, or anything like that. So any thoughts on that?
Yeah, I'm reminded here of the sort of anthropology, sociology concept of audit culture, which is essentially that we focus our efforts and mental energies towards things that are measurable. And because they're measurable, they become the only things that are important. And so we definitely fall for that trap as engineering folks who like numbers and focus on numbers. I think it comes back to sort of requirements elicitation and just thinking about what it is that your system actually needs to be able to do. Being able to measure performance is one part of it, but there must be other characteristics or goals that might be considered deal breakers. So, for example, GovGPT should not give advice that is against the law. That's probably relatively difficult to measure quantitatively, or maybe it's not. Maybe it's actually okay. But there are those sorts of goals and characteristics that we need to actually include in the scoping of when we design these systems, and not just focus on achieving another 0.1% in our Kaggle competition entry.
Well, we have cleared all of the submitted questions, so I'll put out another call for questions, because looking at Andrew's history, he's done quite a lot, so could probably share with us quite a few different things. So we have him here, and so now is the opportunity to pick his brain. Otherwise, you're going to go have to visit a police headquarters, and I don't think they let just anybody in there. So leverage your opportunity now. So while folks are typing in, hopefully some more chats, are there particular efforts that you're working on as part of your role with the police that you think are going to have a really positive impact on society from a policing perspective in the next year or two?
Yeah, I think in the next year or two, I mean, AI is the topic du jour. Everybody is talking about it, and I think there's pressure on New Zealand police because it feels like New Zealand police is behind in two directions. There's law enforcement agencies overseas that have done a lot more of AI, and so it feels like New Zealand police is behind. I would argue that that's not necessarily a bad thing, because just because other law enforcement agencies are like pushing ahead with experiments that may not be well designed and so on, doesn't mean that we should copy them. The other is that in terms of the public sector in New Zealand, there are other agencies that have been trying some of these tools for a little bit longer than police have, which again is, not necessarily a bad thing, in that we can see what others are doing and then try to copy them to do it safely. The observation that I make is that in the environment at New Zealand Police, actually the way that AI will be most valuable for the organization is in all the boring, not sexy back office stuff. There's a lot to do with filing and automatic categorization of reports, even just like spell check. There's a lot of stuff there that we could push our AI efforts towards that would lead to better policing well before people start thinking about the crazy things of like predictive policing or predictive risk models, or building networks of identifying networks of people or anything like that. I think, there's a tendency to think that AI and policing means some of that frontline policing stuff. But where I'm putting most of my effort is in looking for those opportunities in more of the back office.
I mean, I think that's an excellent approach. I mean, allow the people more time and more energy to focus on the high impact efforts that they're making, and reduce that effort of filling out paperwork, which is an absolute requirement to delivering police services, but can be very time consuming.
Yeah, absolutely. And we want to try and make it so that, officers, particularly frontline staff, spend less time in the office filling out paperwork and more time on the beat or actually investigating crime. I think it's more of those sort of efficiencies internally rather than necessarily catching more criminals per se.
See, we've got a question here from Paula. So is there anything that you can suggest to support, enable, or empower the evaluation of AI outputs?
Yeah, it's a difficult and broad question. I think the thing to encourage is to sort of look for ways to move beyond just the quantitative evaluation that can be, easily and automatably done by running your script again, and moving more towards things that include user testing, focus groups, surveys, interviews, those sorts of things, which are more difficult and more expensive. I totally get that, and it's not going to be applicable and appropriate for every project. But I think that is where we're going to be able to get a better understanding of, how is this AI system actually going to be used in the real world, rather than just our conception of how it might be used when we're sitting in front of a computer.
So along the trend of the line of police adopting AI as part of taking care of that back office stuff, has the NZ Police adopted an AI stance or an AI policy and set those guiding principles?
Not at this stage. I'm in 2 days of workshops over the next 2 days with the Australian and New Zealand Policing Association, where they're developing an AI framework. So before we have this framework, which kind of will give us individual questions to ask and answer when we're deploying AI, there are principles that sort of sit above that. And we already have those. So there is something called the Technology Assurance Framework. Anytime anybody in police wants to do something with new technology, they have to bring it through an assessment process to evaluate those risks and to understand how we might be able to mitigate them beyond just sort of technical performance. And by and large, that will be applicable to AI as well, but we'll probably need to have, some more narrow instructions there around what is safe to do or not to do with some of these particularly generative AI tools. In my mind, there is a sort of EU AI Act-esque framework that we can develop at police with very low risk, medium risk, high risk, unacceptably high risk. And we kind of need to encourage people to just take, really small steps. And so maybe initially we only do very low risk and low risk to begin with, but we open that up to the organization. And then over time, as we gain confidence, we move up to the sort of the medium risk and the high risk. And so in my mind, very low risk would be, not using police information at all. It would just be like, I need to make a quiz for my team meeting. Can I use a generative AI tool on my computer at work? Low risk would be starting to use some of that police information that might be, relevant to particular cases, but we might say that it's a subset of cases or subset of crime types. So just trying to really limit our exposure to things going wrong by taking that risk-based approach.
I think that's a really good approach, and one that I think Aotearoa has kind of taken in general to AI. There was a publication in The Economist back in June that across all of NZ, we had some of the lowest use of AI within our research publications. And that's not a good or a bad thing. But it does mean that we weren't one of the highlighted countries that had publications rejected for use of AI.
Yep.
So yeah, there definitely is a lot of value in taking a measured and structured approach into implementing AI. And so we can pivot now to a question on, let's do Maxime here. So do you have any tips on how to reduce decision-based FOMO in the AI space when talking to policymakers and stakeholders, when maybe more time could be spent in waiting to see if this is the right tool? And I think that's kind of on that same line of thought we were on. So do you have any tips on how you can talk to your leaders and your other stakeholders that, it's okay that we don't have AI in everything yet?
Yeah, I think I always just come back to the risks and talking about both sort of impact and likelihood. It's important for us to not sort of overstate some of these risks, because people won't trust us if we kind of keep talking about how AI is going to, destroy the world, and then that doesn't actually happen. But in very practical terms, I think you can talk about things like reputational risk if things go wrong and it gets out in the media and it looks really bad. And you can talk about risks of harm to your affected communities, to your people, sometimes not even people, using AI for environmental systems, for example. If you get it wrong, what is the consequence of that on the natural environment, on the animals and on the plants? So just kind of making sure that people understand what those risks are. And if at the end of the day, the decision maker is saying, yep, I accept and I own and I wear those risks, then that's fine. That's their choice. Of course, they're the one that's going to have to front the media if something does go wrong. But generally, I think I found that is an effective way of sort of communicating to these people, what might happen if you go ahead and do this without thinking about these other safeguards or thinking about this other risk mitigation.
Yeah, with us both being in the public sector, the tabloid test, the headline test, is a really good benchmark for validating if this goes completely sideways, what are going to be the outcomes.
And it is that proportionality test, right? Of do the pros outweigh the potential cons? And kind of making sure that is the question that is being asked. I keep finding systems in the public sector where the pros were all hypothetical, but the cons were real. And then the pros never happened. for whatever reason, like people didn't use the system enough, or it wasn't effective enough, or the data wasn't good enough. And then suddenly all you've done is accepted a bundle of risks and cop the flack for using the system, and you didn't actually get any of the benefit. So kind of, really making sure that we are evaluating those pros and cons appropriately, and sort of, distinguishing between hypothetical and real, I think is important.
Yeah. And so as the police explores how they're going to adopt AI, is access to computing a challenge for New Zealand police? Are you guys able to acquire the hardware and the engineers to work with and understand how AI could be used within police?
Yeah, that's a really good question. I don't think hardware has been considered a limitation at this stage, in part because, depending on what it is that we adopt and what information security controls are put on what things, there's a moderate to high chance that there'll be some cloud component anyway. And so once you open the door to cloud, then your hardware constraints are just monetary constraints rather than necessarily can you get your hands on the GPUs. Police, much like any other agency, also make significant use of external resources. So, even though we might not have the AI engineers sitting inside the organization, we can access them from the outside if we need it. So I think that there's, it's hard to just say AI overall because there's so many ways in which it pops up here and there and different tools that we use. But yeah, particularly if we talk about something like generative AI, I don't know exactly what it's going to look like, but I imagine that it's going to be Microsoft Copilot, at which case, we don't need the hardware ourselves. We're just going to be accessing it from a cloud service.
Mm-hmm. So we have a comment and a question here from Benedict. So thank you, Andrew. It's very interesting. You mentioned that we want AI to reflect our values rather than reality. And so how do we mitigate when some may want to reflect negative values or information?
Yeah, and this is the other sort of 10 slides that I didn't talk about, which would have been what are human values and how do we actually agree on what human values are? Because different people have different values. And that gets very philosophical and political very quickly, which is why I decided not to talk about it today as much. I think one of the interesting concepts that is being tested is this notion of sovereign AI, which has one form of it is focusing on data sovereignty and, making sure that New Zealand, for example, isn't subject to the whims of big tech companies in the US. But on the other end of it is kind of saying, well, actually, it is not possible to create a large language model that reflects the values of all people on Earth, because the values of somebody in Saudi Arabia are very different to the values of somebody in China. Not saying that that's good or bad, just they're different. And so maybe it is such that we do need to have a New Zealand AI that reflects New Zealand AI values, so that reflects New Zealand human values, in order to be able to sort of solve this problem. I'm not 100% convinced that, either way that is what we have to do. I think that we have human rights, and human rights is a concept that's been well defined for a long time, and we have the Universal Declaration and so on. And, if we could even just start with that, I think we would get a long way in terms of making these AI systems safe. But, we're not even talking about that at the moment. So that I would start there rather than going straight to, well, you and I have irreconcilable differences, and so we need different AI systems.
Yeah, I like that approach. I think that focusing in on narrow AIs that are good at specific tasks and specific contexts are probably where we're going to see a lot of value in the coming years, because it is going to be some time before we can create a truly comprehensive AI that can take into account all of those differences, and what is the ideal output of a given input. Let's see. So we've got about 15 more minutes in our scheduled time. We did happen to start about 10 minutes early. So I do appreciate everybody's fantastic questions and our fantastic keynote speaker. It has been a wonderful conversation. I wanted to give one more call for questions or comments or any input here before we take a short break for morning tea before we continue on. And and Mercedes will be back in a minute or two to give some administrative and agenda type updates for everybody if we don't have any more questions for Andrew.
Maybe I'll touch on this last
Yeah.
question here just to wrap things up. So we have a question here from Hillary that there are some smart people who genuinely believe AGI, general intelligence, if achieved, will probably destroy the world, and silencing them might be a bad idea. So my personal take, my P-Doom, the probability of artificial general intelligence leading to the demise of humanity is 0. And that is only because I believe that there are other things that would probably lead to the demise of humanity first. And I often find it odd that in an era of where AI is moving so fast and that people are talking about it and it's all changing, that we've somehow forgotten about climate change, and that there are actually other existential crises that we have to not lose sight of. So that's a final cheery thought for me.
I think it's a good one to done. It's important that we don't hyper focus on one particular aspect of society. Given this talk was on bias, and that is a big play on how we take ethical, security, privacy, legal considerations into all of the things that we do. And today it's AI, and tomorrow it'll be something else. But we do need to make sure that us as humanity are keep putting our best foot forward with all of our decisions. So thank you, Dr. Chen. I appreciate it. I'm sure every one of our attendees does as well. It was an amazing hour. We've got to enjoy listening to you and your thoughts and your experience. So join me in extending him a thank you, and then we'll bring Mercedes back on.
Yeah, thank you for having me.
Thank you so much, Dr. Chen. A very interesting talk and great to have some insight about the biases in AI. I think it's really relative in this industry right now. And thank you as well, Michael, for leading that. We are 10 minutes ahead of schedule, but I do know that people have planned their days around the scheduled break times. So we will just have an extra 10 minutes for that morning break. Our next talk is planned for 11:30. So we'll take our break now, come back at 11:30 for the next presentation from Dr. Petra Milner, and then, we'll continue on with the day. So our next chair is Dr. Olivia Angelin Burnett, who will next take us through. So we'll see everyone back here at, I'd say, 11:25, and then we can get going from there.